Hi everyone, I'll be discussing about 2D clipping. So in 2D clipping, the major, the important concept that you should be knowing is how to make transformation from window coordinates to viewport coordinates. So what is this window coordinates as well as the world coordinates? We call this as world coordinates. Window coordinates are called as world coordinates and viewport coordinates are called as device coordinates. How do we make it? So what do you mean by this world coordinates? Assume I have a scenery here. Something, a tree. Fine. I just don't want to display the whole content. I want only this portion of the tree to be displayed. So this window is deciding what to be displayed. We call that as window as world coordinates. When it comes to device coordinates, we have to decide where it has to get displayed among the device. So assume this is our viewport through which where the object displays. So we have to decide where to display it. So I can see only this much. So we call this as viewport or viewport coordinates or device coordinates. Okay. Now let us take a small example. With respect to window, consider this is my window. I'll take this as XW min and I'll take this as XW max. And I take this as YW min and I take this as YW max. Fine. Assume I have an object here. This is with respect to world coordinates. When I display this with respect to device coordinates, what happens? The size of the object doesn't remain the same. It actually changes. So, with respect to viewport, consider this as XV min and this as XV max. Fine. And this as YV min, this as YV max. Assume there's a point here XW and YW. This has to be displayed to the viewport now. So at the point XV comma YV. Fine. So actual objects, when we display to the device coordinates or the viewport coordinates, the size of the object will be small. So the scaling happens. So that we have to keep it in mind. Even though the size differs, the position where it get displaced inside the port remains the same. Means the relative position is same. Okay. So how do we we'll get to know the world coordinates very easily, but in order to draw it to the viewport, we have to know the XV and YV value. So in order to derive an equation, we have a theory where XW minus XW min, XW max minus XW min is equals to XV minus XV min divided by xv max minus xv min. Fine. Similarly, for yw minus yw min divided by yw max minus yw min. So what I am doing here, xw minus xw max, xw minus xw minus xw min I am taking, and y max minus y min I am taking. So whatever might be the position of here xw, this minus this I am divided by this minus this. Here also xv minus xv min divided by xv max minus xv min. Similarly, it holds for y also. Fine. From this we can derive an equation wherein which xv minus xv min, consider this, it is nothing but xv max minus xv min xw minus xw min divided by xw max minus xw min. Now xv is xw, I can write this as xw minus xw min. I am taking this outside, and xv max minus xv min divided by I am writing this way now. So we have moved this to here, this side, that is plus xv min. Xv equals, I'll write this xv min here, plus xw minus xw min. This whole thing I'll replace that as a scaling factor is 6. Similarly, for yv, it will be yv min plus yw minus yw min into sy. So from this equation, we try to find the relative positions, that is xv and yv, in order to draw to the viewport now. Fine. Consider a small example now, where your xv min is 30, xv max is 60, yv min is 40, yv max is 60. You need to find xv and yv in order to draw the points on the viewport, that is on the device coordinates. And with respect to world coordinates, I have xw min is 20, xw max is 80, yw min is 40, yw max is 80, wherein which my xw and yw is 30 and 50. If you want, you can, like, you consider this equation now. xv is xv min, that is 30, plus xw is, what's the value of xw? That is nothing but 30. xw min is 20 into sx. I'll just abbreviate the value of sx. Sx is nothing but here sv max minus sv min. So that is sv max is 60 and xv min is 30 divided by yw max is 80, yw min is 20. Fine. So solving this, I'll get xv as 35. Similarly, for yv min is 40 plus yw is 50. It is 50. 50 minus yw minimum is 40 and I'll abbreviate sy. Sy will be yv max. Yv max is 60 minus yv min. Yv min is 40 divided by xv max, yw max 80 minus yw min, that is 40. Solving this, I will get yve as 45. So my xv and yv will be 35 and 45. Is it clear? Related to this, consider a small example wherein which we have a different window and same viewport. Okay. Consider the axis wherein which I'll just draw this house. If this is xw and this as yw, consider my window is this now. This is my window. So how will I draw it in the viewport? Xv and yv. It will be something like this. Correct? So let us take a different window now. I have a same object, a house, but this time my window will be this. What happens in that case? In the viewport, so if this is my viewport, so what get displayed? So this get displayed. So based on the window, whatever I choose, it relatively draws in the viewport. How does it calculate these points? As I have explained here, it makes use of this equation to calculate the points of xv and yv that is being considered to draw it in the viewport. Fine. Now let us take a different case. Means same window but different viewport. Means same window and different viewport. How it works? Consider the same object. Consider this object. Consider this as my window now. So this is XW and this is YW. So with respect to viewport, consider this as viewport. This gets drawn. Fine. Now the window remains the same, means my clipping window remains the same. Means it remains the same, but while displaying the viewport, I might have drawn my viewport here rather than here. Okay, my objects get displayed here. I think I am clear. Why we need all this concept is, while clipping any line, well, that is 2D clipping, is keep remember all these points so that it helps you like how actually the the graphic system works. Bringing all this concept together, let us consider one example now quickly. So consider this axis XW and YW. Listen to this carefully. Consider I have an example, something like this, and this is my window. Fine. So can I just say what will be the coordinates here? This will be, of course, XW min and YW min. Correct. I have to bring it to the origin in order to perform the clipping operation. Means something like this. Consider this as axis. So to bring like this, so here it falls my clipping window. That is, we have to make a translation with respect to minus XW min and YW min. Correct. Can I write that homogeneous matrix of this? 0. I have explained this in the previous video. XW min minus YW min. Okay. Now, as I said, once we draw, take any point from the word coordinate and draw it to the viewport, the scaling happens, means the size of an object varies. So with respect to Sx and Sy, the scaling happens. How do you write the homogeneous coordinates for this? It will be Sx and Sy. So we are representing in 3D vector. Hope you know what is the equation of Sx and Xy that is being discussed, which we discussed here. So we'll be calling this as Sx as well as Xy. I'll just write it down for your reference. That is Xv max minus Xv min divided by Xw max minus Xw min. Similarly, with respect to Sy, it will be Yv max minus Yv min divided by YW max minus YW min. Okay. Now, yes, we are done with scaling. Again, we have to shift back to the original position, the window. So how will I do that? Means x, this will be not W. So we have been shifted to, from this we might have calculated XV and YV. correct? So this will be xv min and yv min, not w, because at this point we'll be drawing the coordinates, means this line, to the viewport. So in that case, this will be xv min and yv min. This will be xv max and so this will be xv max and yv max. Fine. So in that case, I have to perform a translation, reverse translation function, but with respect to xv min and yv min. So how does the homogeneous matrix look like? It looks like this: xv min, yv min. Okay, I'll just write down this in an equation format now. That is, hope you remember in previous video wherein which what are the sequence of operations that we have to perform here. First is translation, scaling and reverse translation operation. So this we have to, I'll call this as RM, just an indication, RM. So I'll be multiplying this RM with old coordinates so that I get new coordinates, that is V. Fine. So on doing this operation, RM is nothing but all these matrices with respect to existing xw and yw, we get the new coordinates. See, this is somehow related to this. We have this, all this value, right? We manually calculated this once, but what happens in graphic system is, it takes this RM. So with this, as we saw this example, it takes 30 and 50 here, 30, 50 and 1 multiplied with this, all this 1, 2 and 3, all these three matrices, will get xv and yv, that will be 35 and 45. So this will be fed to the system. Here we have manually calculated. So thanks for watching the video.